Great. I think we are ready, and I will start with one question we got from the online audience. But of course, if there are questions from the in-person audience, we'll go back and forth a little bit. So the question says, I love the idea of having operationalizations of hypotheses through LLMs, but I'm concerned about the ability to actually do that given their black box status. If you have a hypothesis about something specific, for example, a syntactic representation playing a particular role in, say, human contextual disambiguation, how could you know that the LLM-based I hate this word, operationalization, whatever it is not a confound of syntax and other factors like lexical association?
Okay.
Yeah.
How did you know that I wanted to do it?
I don't know, you just looked like you were ready.
Yeah.
And Roger says we need to talk right into the mics for people to hear.
Right. So I think that we tend to exaggerate sometimes how black box these models are. And I think that the methods that David talked about in his talk, and we've also used them to some extent, are more effective than you would think. And we need to spend even more time developing those methods even more. So that's and we can definitely construct models that are more interpretable than the models that OpenAI releases to us. So those are the two parts of it. First of all, post hoc interpretation methods like the ones that David mentioned are more effective than people think, I would say, and they're getting better. And the second one is that, especially for syntax, actually, if we have pretty good approaches to creating models that have explicit syntactic representations that we can analyze and manipulate, saying methods like recurrent neural network grammars, for example. That's an example. So that would be models that are interpretable by design. I think that's harder to create for phenomena such as world knowledge or some aspects of pragmatics, but maybe that's another direction we can go in. Okay.
Okay. All right. Sure. I think is that?
Yeah, it should be fine.
Okay.
Okay, this is a little bit related, but I don't apologize. It's sort of a crass question from a language model engineer and sometimes linguist, but not a psycholinguist. But I'm still feeling a little bit dissatisfied because the theme of this session was meant to be what insights do large language models provide for the study of human language. And I sort of feel like I saw quite a few ways in which the representations of large language models were reasonably correlated with human language processing, and some ways in which they weren't. But I'm still feeling a lot unsure what insights I've gotten into human language processing. So is there a way to get a sharper notion of whether this is giving us insights into human language processing?
May I offer? So I'm speaking only for myself, so it will be for you guys. I think that it offers a tremendous insight because it offers a different way of modeling language in the brain. It offers a different paradigm. So I think that when you are talking about insights, you look for traditional insights we used to see from linguistic work or psychological work. And I'm guessing that there are there. But for me, and the reason I find now it's not just large language model, right? It's also multimodal. This way of thinking about cognition through a model that optimizes next port prediction or some other function. It's, again, to me, it's another way of thinking about cognition, thinking about an organism that does this specific or relatively simple task. And we can see that the representation it induces are somewhat correlate. I don't know, 0.3, 0.5, it's low, it's high. I don't know, it's as high as it gets in neuroscience. And perhaps what it suggests that instead of looking for these interpretable insights or interpretable embedding and representation, we should start think about these acting models in the world and to see if they offer an alternative explanation to how to think about cognition. Then these series of heuristics and insights that are interpretable, but not more expressive or predict or have predictable power of the brain. But again, this is my perspective.
Sorry, I have something to say about that too. So, I mean, I think if you think back to the earliest days of cognitive science, right, there was a huge, not just a debate didn't start, but a debate quickly resolved itself between, the strong empiricist position of learning and associations as the primary engine of cognition and language being overtaken by a very different perspective, and it gets kind of lost now. But there were sort of two different arguments there, right? So Chomsky's argument was that you need a set of rules in order to do things, right? And in Syntactic Structures in 1957, he presented kind of three primary arguments, right? He had the argument about color screen ideas sleep furiously. He had the argument about long distance dependencies, and he had the argument about the relationship between different structures of sentences, actives and passives, questions and statements, and things like that, right? So there was the sort of Chomskyan idea that you need hierarchical structures and formal rule-based hierarchical structures in order to solve these kinds of problems, right? At the same time, you had Jerry Fodor arguing that you need a certain type of set of categories and the relationships between categories in order to do systematic semantic compositionality, right? And these were sort of two different arguments that really went well together. But I think the thing that large language models are doing is helping us see that they're actually different and that one of them is a more serious problem than the others, right? Because I think what large language models have shown us is that a lot of Chomsky's specific concerns that he laid out in 1957 are solvable with a lot of data, right? We have color screen ideas sleep furiously is a non-issue, and large language models don't do non-adjacent dependencies exactly like humans do, but they do solve non-adjacent dependency problems, right? And the relationships between sentences or statements and questions and actives and passives is maybe a little bit more mixed, but still pretty much there, right? Whereas the Jerry Fodor problem of compositionality is a more serious one, I think. And so I think one thing that large language models have done is highlight that of the original types of arguments that were made in the early days of cognitive science, the sort of Fodorian kinds of concerns are more serious and ones that people who are interested in the more empiricist answer need to continue to work on those types of problems, whereas the more Chomskyan concerns are maybe lower in seriousness. I guess that would be one answer I would give.
So I think your question is maybe a little bit antagonistic, but in a good way. And actually agree that we're very much at the infancy of understanding what these things tell us about humans. I think the way that we're going to make progress here is exactly the way that we've always made progress, which is in the context of theory and doing hypothesis testing. And these are tools that allow us to operationalize some hypotheses sometimes. In my talk today, I talked about operationalizing sufficiency arguments. Is thing X sufficient for Y? But I think there are lots of other ways that people are already starting to do this, looking at the content of training data and seeing whether the presence or absence of something in training data is sufficient to lead to a particular capacity later on. Whether like Raquel was talking about, whether the presence of information in different modalities is necessary for the development of particular capacities and so on. And these all sit in in theoretical frameworks where there are hypotheses about the necessity or sufficiency of these things. So I think that is the direction of work that's going to start to answer that question.
So just to add to what's been said already, I also think that perhaps right now we're in a deconstruction phase where we're kind of removing some of the insights we already had, I would say. And then it's probably just going to take time to get to the point where we're going to have new insights that are built on the tools that we have now. And we might also have to be comfortable with the fact that those future insights might not be simple and sayable in one sentence and easy to deliver. They might also be complex. And that might just have that might just be something we'll have to deal with.
A quick follow-up to Ben's point, which I totally agree with, is the nice thing about being able to train language models ourselves is that we can do causal experiments on the training data, see what happens if you remove a construction but keep the rest of the training data the same. And then that's the best way to test the hypotheses, I guess, that Ben mentioned. If you think that the way that you learn about certain restrictions on long distance dependencies is from a specific kind of sentence, you can see how many times a sentence appeared in the corpus and maybe increase that amount of times, or remove all of that example of sentence from the corpus and see if the model still learns the same thing. Then maybe that specific construction is not necessary to learn that constraint. It's a kind of work that maybe Kyle is going to talk about. Are you going to talk about this? Okay, great. Yeah.
All right, let's do another online question. So this one says, of course, we've all been swept up in the excitement that began with BERT years ago, but it seems that for many tasks, so this is asking about new uses in computational linguistics in particular. It seems that for many tasks, such as simple topic modeling, sentiment, et cetera, the resources and time required to leverage the power of GPT or something like that do not feel justified by the marginal improvements over simpler approaches. So from a theoretical standpoint, the apparent improvement in semantic parsing by these models is cool and exciting, but are they truly more useful in most empirical computational linguistics research settings? And are there examples that we can point to of those?
Right. So I mentioned briefly before an example from my lab, right, which has to do with a face-to-face conversation in this case, right? So in face-to-face conversation, you use different modalities jointly, you use gestures, you use speech, and so on. And as I said, there is quite a lot of interest from cognitive science actually to have computational linguistic tools that allow us to build representations of these multimodal signals, so that we don't have to go through very time-consuming annotation, for example, so that we can build representations that we can reasonably trust, right? In a similar fashion as we before used to use part-of-speech taggers, for example, and they provide us a lot of useful information, for example, to analyze in corpora what kind of part of speech were used in child-directed speech over development, for example, right? So now we have more powerful tools that allow us to build other types of representations, and then these tools can be used by cognitive scientists and others to analyze at a larger scale different aspects, right? So in our case here, we were interested in patterns of how speakers interacting in a dialogue may mimic each other at the level of gestures and at the level of speech. So with these representations over which we can calculate similarity, then we can study these kinds of phenomena, for example.
Question which I'd like to ask for all the sessions, and it is very related to the questions about modularity or what the LLMs can provide for the static language. And here's my question. So before LLMs, And before this very successful ability that LLMs have demonstrated in generating very, very fluent linguistic output, the study of the language was a bit modular, right? So you would never expect, for example, when you were modeling a syntax, right, that this model would, would be expected to be truthful to the information that it contained. And even when you did the semantics on top of the syntax, again, it was just the things that were semantically plausible, right, as was mentioned. So there was no expectation that the information would be accurate. That was part of the NLP problem. And now it seems that it is, right? It seems that we're complaining about LLMs when the information is not accurate. Somehow, because of, I guess, because of the data the models are seeing, that somehow this encodes some information in that. And my question is, what is the relationship between the two? Is it, should we stop expect LLMs to be truthful and have like a different model that will do that? Or should we look at the study of language in a different way? And stop thinking that it is this kind of system that, first we do the syntax and we do the semantics and then some other module will do the information, right? Actually at NSF, the information retrieval proposals are handled in a different cluster than when the foundational NLP proposals are handled, right? So is this a distinction that should be kept? Or do you think that what we're seeing from LLMs maybe is changing how we see either LLMs, how we should be seeing LLMs, or how we should be seeing the study of language?
Again, my opinion is that, well, regardless if we expect LLMs not to, regardless if we expect them to be accurate or not to be accurate, there will be effort to make them more accurate because it's useful. But the other aspect of your question is that I think, and I think that I discussed it a bit, is that there is an alternative. It's not an alternative, it's somewhat complementary to this rigid, hierarchical, symbolic, interpretable approach introduced by linguistics of phonemic, morphemic, syntactic, semantic, pragmatics, right? I mean, we do see these concepts in LLM. We can analyze them and find syntax and find semantics and find phonemes, and it's there. But it's not what all is there. And I think this goes back to the earlier question of what these models offer about language, is that things are more interconnected, that there are some currently uninterpretable representations that are also likely to be relevant to the human way of representing and generating language than the way we used to think about it. So I think that the terms that we had so far are, I think it suggests that we need to think about them as biases that the model has, but it's not fully constrained by them. There is more, and these models are a way to see it, right? I mean, they allow us to consider new type of theories, one that generalize, does not replace necessarily, but generalize beyond the interpretable concepts that we were all trained on.
I think it's, this intersection between the engineering applications of these very large AI models and these more ancient questions of how human thinking works is very interesting, because I think that for a long time our assumption has been that human cognition is sort of a ceiling for our models, for what we can possibly model, and clearly we're now in a regime where we're exposing these models to so much data that's of a scale that's not really human-like, that really you have a Venn diagram of there may be types of processing that humans do that the machine-trained models cannot do. And there is some intersection where maybe these things are doing things in a shared way. But then there's also this very interesting set of things where we're exposing these large models to so much data, and we're giving them certain architectures where they may be processing information in a way that's not human-like. And I think that's also interesting. I think all three of these parts of the Venn diagram circle are all interesting. So, some of these may be new, things that we haven't traditionally had an opportunity to explore. And so, I just sort of point out that it's not necessarily a crisis of modularity, but maybe a moment to rethink. The way we're organizing, the way we're navigating the field. But I think that if we're holding models, I think that from an engineering point of view, people will hold these models to a very high standard. They're going to want them to be more accurate than humans can be. They're going to want them to be able to do reasoning that's more complex than an average human can do, and so on. People will continue to push this engineering question forward. I think that will probably give us insights at the intersection, but it may also give us some new kinds of insights about cognition where the human model may not be the ceiling anymore. So I think that's quite interesting also, and maybe humbling in a certain way.
Sure. Yeah. So I think it's probably a useful idealization to divide language into modules, but it's clear that they kind of spill over into each other. We have just an example that's on top of my mind. When people reason over kind of logical statements, the content, the meaning of the statements affects their responses. So our reasoning is not fully abstract. It's somewhat abstract. It's also not fully tied to the meaning of the specific words, but there's like spillage between those two things. So there's some modularity, but it's not perfect even in the human mind. The other thing is that I feel like right now the fact that knowledge and like more formal linguistic competence are so entangled in language models is not seen like a good thing by anyone, probably. I mean, just like I think most of the approaches in AI right now are some sort of hybrid of large language model and a more traditional kind of retrieval-based approach. And I mean, one example that's like maybe an obvious one is the time dependence of the knowledge that's encoded in the weights of the model. Like the most recent Olympic Games were in blank. Like the answer is going to be different if you train the model now or in August. That's clearly not the right way to encode that knowledge. Like you want to have some sort of database that's continuously updated that gives you the facts about the world. So I think we're going to see more modularity in the LLM world if we're not already seeing it behind the scenes in GPT-4. I mean, I don't know what's happening in GPT-4, but I bet that there's something like that that involves retrieval from a database behind the scenes somewhere. So, yeah.
I also want to add that this modularity that we know from linguistics, we kind of achieved it by thinking at the computational level. And it's not necessarily the way to implement a system that would do these computations. And so when we look in the brain, there's not this nice distinction between, like, let's say, syntax and other types of information. It all seems to be fused together, probably because it's not necessarily the way it should work on the most basic level. And so that's probably why it's true also in large language models that that necessary step that seems so essential to us as speakers of language and very, very clear to us. We're maybe just like badly positioned and a little bit biased on how the entire system should look like. And so maybe those organizations we have are not necessarily a requirement for having a system. Maybe they're something that results from learning to do language. So we just have to keep the levels in mind.
I think something that is really important to think about with these models is that their ability to do semantic plausibility and their difficulty with factualness are two sides of the same coin, right? So the fact that they can so easily generalize is exactly what's causing the hallucination problem or whatever. And that's a problem that needs to be figured out. And of course, you know, some people think that that's why you need this completely formally different system that behaves completely differently. And it's possible that's right, but there are also possible solutions that are more, I don't want to say tweaks because they could still be large changes, but still fundamentally behaving within the same kind of a system and the same kinds of architectures, but just changing how they work. So you can certainly imagine that, again, if you are not just doing sequence prediction, but doing reinforcement learning that involves some sort of reward and punishment for saying accurate things or not saying accurate things every step along the way, that's going to change the nature of exactly what representations get learned. And you can also imagine, and that's sort of thinking about it from a production perspective, but even from a comprehension perspective, you know, when you are listening and comprehending and trying to predict the next word, you're not just trying to predict the next word, but you're building this more complex model of what the speaker is trying to say and their communicative intent and all that kind of stuff. And there are ways to try to tweak a system like this that is going to, you know, be better at that, I think. So I think that's another, it's at least one possible route. I think it really depends on how fundamentally do you think that you need a completely different system versus changes to this kind of a system to change how it works. I have my sympathies in the tweaks to the system kind of a thing, because I just have trouble believing, you know, when I think about like talking with my 3-year-old daughter about what she had for dinner last night, versus asking her to tell a story about what her teddy bear had for dinner last night. The idea that these are drawing on completely different systems and different representations and different knowledge stores just seems not right to me, right? It's a small shift in attention where in one case you're focused on recalling a specific event that happened to you. In another case, you're not doing that and you're filling in with some other kinds of things, but you're using a lot of the same shared representations. Seems like the right way forward to me.
I'm sympathetic with that point of view, right? So, so I think, you know, yeah, I think one of the we've always had challenges when trying to divide up these modular sort of ways of thinking about cognition with things like common sense reasoning. Whereas, you know, show me the success of you know, modular database of common sense understanding that water is wet, that, you know, that things fall down when you drop them, and, you know, that, you know, penguins live in the cold and so on. Things that, you know, are not expressed so well in Wikipedia. I think, you know, and yet, this is exactly the kind of reasoning that these statistical language models, they excel at so well. I mean, they've solved this common sense problem, and this type of common sense knowledge is the kind of knowledge that you need to compose with other parts of a query to understand what you're talking about. And so I kind of feel like, you know, if we assume that, you know, that the models, because they're getting some facts wrong, that the right solution to it is to draw a hard boundary and to, you know, impose some modularity on it, to do it a certain way. I think that we need a little bit more humility, right? And you know, realize that they are showing some strengths that are a little different from the way that we've thought about the problem in the past. But I, you know, not to you know, say that they're not missing something. But yeah, I think that the solution may not be, you know, may not be what we envisioned, you know, not too long ago. Might be more complicated with more tweaks.
Time. Do we have time for one more, or should we?
Okay.
I'm going to not ask the exact question because I'm kind of drawing across a couple of online questions that really get at the heart of how much does the input part matter, right? We haven't really talked, although you did a little bit, about the decoding of the speech or the orthographic decoding and how much of that plays into what humans do and can do versus the models.
Well, I don't know exactly how much it matters, but I think that, yeah, this is one of the factors, right, that that is important on how you, on what kind of language model you should pick up for a certain type of analysis or of investigation, right? And yeah, I mean, it's true that typically we use the most widely used language models are trained on text, and obviously that's not the input that we humans use to learn language, right? So mostly that comes from speech, and speech situated in social environments and so on. So obviously there is a huge difference there. Whether this invalidates anything that we can say from language models, I don't think so. But I think it's an important factor to take into account and to keep it in mind, right? And yeah, so therefore it would be very interesting to see what kind of differences you can, whether you can pinpoint differences in how a language models aligns to human behavior, depending on the type of input that it has received for training, right?
Also, as I've shown, we are not limited to text-based only models. There are multimodal models who get this input, and I think that to me show very convincingly that this approach works, right? I mean, when you take a model with a different task of deciphering the words from the acoustic stimuli, we find a similar representation to the brain in the way where we expect them to be in terms of the things that are more audio related. We see them more in the superior temporal gyrus. Things that are more semantic related, we see them in the IFG and the angular gyrus. And we also see, which is, there is a debate if it is novel enough or not. Well, it's a debate we have now with the reviewers that we see this information in all areas, in different biases. So, and I think that and this is obviously, by the way, not the right model, because as said before, we are not just about predicting the next word, right? I mean, we are also trying to understand the emotional state of the person we speak with. We're trying to understand the social environment that we are working in. So there are a lot of things but again, it falls nicely into this framework because these different things are basically different or more objectives that we can introduce to future model. So it's about the input, it's about the objective function that we are trying to optimize. And the more we will understand what we want our cognitive models to capture, the better the models we will train, as Tal suggested, will capture human cognition and human behavior.
I'm going to ask a question to all the speakers, just briefly. So going back to the sort of question of the fundamental question of the theme of what insights can large language models provide to the scientific study of language? You know, there was a lot of emphasis on sort of the applications to studying human language processing in both behaviorally and its neural implementation. But one might be, and I think, you know, we've seen a lot of evidence that really we're going to learn a lot from using these either as baselines, as Ben has done, or as encoding models, as Leela and Ariel have done. But we might hope that we can go beyond processing to actually the structure of language itself. You know, what are the fundamental representations of language in the human mind and brain in a way that is not only sort of that we can predict them with the models, but we can actually interpret them and understand those representations. And so, for example, to take the case of meaning, you know, so before large language models, in a lot of ways, many people might have argued that the leading theory of linguistic meaning is captured by formal semantics from philosophy and linguistics and logic. But there's, of course, many things that kind of theory doesn't capture. And as Ben alluded to, we have the distributional hypothesis, which is another way of looking at where meaning comes from and how to think about it. And I think we all have the intuition that clearly LLMs are capturing features of language meaning that are not really well captured by logical approaches alone. And that probably what they're doing is picking up on things that people have tried to articulate but have had a hard time formalizing with distributional techniques. That being said, we're now 70 years on from when the distributional hypothesis was first formulated, and it would be nice to think that we have something that is a theory which is scientifically interpretable to a human of those aspects of meaning that we are not captured by logical approaches. But how is that something we can hope for, and what might such a sort of human readable theory like that look like?
Thanks for saving the easy question for the end, Roger. So obviously I don't know the answer. I would point to a couple of other kinds of theories of meaning. There are these embodied theories of meaning. There are also continuous theories of meaning that treat language representations as part of a complex dynamical system. We have a new paper out, Sean Trott and I, in Psych Review that uses large language models to kind of test this sort of notion that goes back to people like Jeff Ellman saying that meaning is not a representational thing, but meaning is the effects that words have on your current location in a state space through processing. So I don't know if that's human understandable or not. Trajectories through state spaces aren't as nice as dictionary entries in terms of human interpretability of theories, but that's one direction that maybe this will help us out in.
I'm not sure whose tasks is it. So if we try to understand how the brain deciphers language, produces language, the brain is not a scientist. It's not a linguistics. It doesn't care about having interpretable mechanism in it. It cares about what works, and what works may be not interpretable now. It may be not interpretable ever. We may build our intuitions about what we know that's going on. I think, as earlier is being said, I think that these models are being classified as non-interpretable too much, and we actually know pretty much about large language models. So if you think about it, when we think about it from understanding what the brain is doing, I think the interpretability question is less important. I think that when you think about it from a linguistic perspective of like physicists who are trying to understand some phenomena exist in the world, perhaps it is more important, but perhaps it's a good example of physics. In physics, a lot of the time there were phenomena and even explanations that were not interpretable. And then, let's say, quantum mechanics. And with time, people build their intuition around what best predicted the results. Saying that it became interpretable, I think, will be a stretch. So it depends on what you are trying to do.
Yes, I mean, I think, one thing we need to do is understand even what we mean by meaning. And that's something that, we argue about. I mean, you can think of, formal semantics is engaged in a very different enterprise, right? They are trying to come up with a set of rules to generate true and only true sentences, all possible true and only true sentences or something like that, right? And that's an interesting endeavor, but it's very different from, I think, at least as a psychologist, what I'm interested in doing. And you can think, another approach was the behaviorist approach, which is try to understand all of the behaviors, right? And meaning is just what people do, right? And that's another answer, but is one that at least most of us cognitive scientists don't want to go that route either, right? So to a lot of us, meaning is the relationship between the behaviors and some set of representations that lead to those behaviors, right? So it's the relationship between them. And yeah, I think the distributional hypothesis is one answer, and it's it was originally posited as, in contradiction to some of the formal approaches and in contradiction to the embodied approach, but it's not in any way, it's orthogonal to the embodied approach, right? You can have distributional processes operating over objects. In fact, there's a lot of interesting work in my lab and in Brendan Lake's lab and in a lot of other labs, looking at taking distributional approaches to objects as well, right? So I think that, that what I've always understood that we're trying to do as cognitive scientists when we're studying semantics and meaning is just trying to understand what are the representations that give rise to behavior and how do those representations come about. And large language models are obviously, to some of us, an interesting step toward figuring that out, but right now we're not. I mean, it's the interpretability work and a lot of that we need to do a lot more of to really figure out what are the representations. And we seem to get very different answers, whether we're looking, in different types of models too. So I think there's just a lot more work on the interpretability end needs to be done to answer your question, I think.
All right, I think it's time for lunch. Thank you so much to the speakers and commentators again.